Okay, everybody, this is our lab session for October 12th. And I think people like this video function so much, I actually have nobody in lab with me today, but I'm still going to go ahead and review my lesson plan so that you guys can watch it from home. Okay, so the first thing that I put together, what we're going to do today is look at the formulas for the z-scores, and then also I'm going to go through an introduction to SPSS, because next week in class, Callie's actually going to lead us through a lab in SPSS doing t-tests, and so this is just a primer for that to get you, more comfortable with the software, so that once we do that, you'll, be able to follow along with what she's doing a little bit better. But first, just in the interest of helping you guys to complete your problem set for this week, I put together, just to have in one place, the z-score formula and the confidence interval formula. So to start, the z-score formula is z equals xi minus x bar over s. And so what that translates to is that your z-score is equal to your observed value minus the sample mean over the standard deviation of the sample. So in most of the questions in the homework, it asks you about a particular value, like what % of people make more than a certain salary level. So that's going to be your observed value that you want to put in the place of x sub I. In other questions, it asks you about, it defines the percentage of what percent, for example, at the 95% or 99% levels. And so that is basically the same thing as giving you your z to start with. And then you need to solve for the x sub I level observation that would amount to. So I just did a little bit of the algebra for you there. You would multiply both sides by s. So you get z times s equals x sub I minus x bar. And then adding x bar to both sides, you get x sub I equals z times s plus x bar, the average, the sample mean. And then for your confidence intervals, what you're going to do is take your sample mean, again, that's x bar, plus or minus z times the standard deviation over the square root of n, which is your number of observations. And so as a reminder here, for a 95% confidence interval on two tails, is your z-score is going to be 1.96. So you take the mean plus or minus 1.96 times the standard deviation divided by the square root of n minus 1. And, oh, I'm sorry, that's a typo there. For a 99% confidence interval on two tails, your z-score is going to be 2.58 that you need to plug in there. So you take your sample mean plus or minus 2.58 times the standard deviation divided by the square root of your number of observations. So for, and as a reminder there, we have the standard deviation formula. I don't believe that it's necessary that you calculate that in any of the questions, but since that is part of the other formulas, I just thought that it belonged in the same handout. So I will be correcting this and uploading a new handout to the section on the lab page on our Canvas site. So hopefully that is a little bit helpful. One other helpful trick, I know that looking at those Z tables is an important part of every statistics student experience, but there are some really easy online tools. I included a link to one here called measuringu.com. And so what they have is the ability to just enter your z-score or your observation and be able to do that computation for you. Although it doesn't seem that the internet is cooperating at the moment. There we go, measuringu.com. So if you have, the confidence interval calculator is a little bit more complicated. I wouldn't recommend doing that right now. The two things that we're going to focus on is the percentile to z-score calculator and z-score to percentile calculator. So this is going to be the primary one, z-score to percentile calculator, that you'll be using or might benefit you in your homework. I would also recommend perhaps using your z-tables first to get an answer, and then perhaps checking your work utilizing this function. Okay, so for example, when you have the question that asks you about a range in between two, say you calculated a z-score of negative 1.4, and for a one-sided test at the 2 decimal point place, you can see, that we have 8.08% falls below a z-score of negative 1.4, and 91.92% falls above a z-score of negative 1.4. So then if you were calculating a range and then you wanted to know between that and a 0.7 z-score, then you would do the same thing, and it's really helpful often to draw out your little diagram and take a look at this and see. So if we had 8.0% 8.08% below before, so you would subtract that from your 75.8% below here in order to find the difference. It's really helpful to draw that curve and see. So that is for when you're doing a one-sided test. So that's when you want to know how much is either above or below a particular point. But when you want to know distributed on both ends, for example, your 95% confidence interval, you would want to look at a two-sided test. So from our known significant z-score value of 1.96, we can see that 95% of all observations are going to fall between, because it's two-sided, that's considering the plus or minus 1.96. So the above or below will just be 5% out of the 100% of all observations. So you can see that there. Alternatively, you can utilize the percentile to z-score calculator. So this was z-score to percentile. And if we go back one more, we can see the percentile to z-score. And again, we looked at, this will help verify our significant values. So if we wanted to know on a two-sided test, 99%, what our significant z-scores would need to be. We'll do 2 decimal places as a general rule in this course. And we can see that 2.58 is our significant value, which accounts for 99%, so only 0.5% is in either tail. So if you use 2.58 as your significant value in constructing a confidence interval or using it in the formula to determine what the observation value is for that question, then you want to use a significant value of 2.58. So hopefully those things are helpful. I will publish the updated version before I upload this video, so it should be all ready to go for those of you who are watching. So the next thing that we're going to do is go into take a look at some SPSS problems, or not problems, but we're going to take a look at some data and get a little bit comfortable with the software and see what we're looking at. So we want to start by going to download the data. So we're going to go on Canvas to Lab Files to Client Dataset 14 Save, which is already in as an SPSS document, or I mean formatted file. So we can open right straight here with SPSS. Often SPSS takes a minute to open. So I just wanted to make a note while we're waiting here for that, that the additional document there, the Lab3 docx, was a similar type of simulation that Callie took her students through when she had taught this class as a TA previously. And so it includes some different instructions and some references to problem set 1 that was different for the course at the time that she was TAing it. So those references are not valid, but it does go through step-by-step how to, save files, open files, and do some different functions. So it might be helpful, but just keep in mind that that document was prepared by her for a different course, although it was utilizing this data, but some of the other outside things that it references to are not necessarily valid. So keep that in mind. Okay, so what we have here in opening our client dataset 14 is we have, if you look down below, just like Excel, we have 2 different tabs, except for instead of being 2 different spreadsheets of data, it's 2 different ways of looking at our data. So the first one on the left is the data view. And this is basically, it's a spreadsheet. It includes all of our cases and all of our observations, all of our cases going down on the left. And the columns are all of our variables. So it's pretty basic there. If we want now the variables, there's quite a few. You can scroll across and see that there are a number of different variables we have. And then there's also blank spaces where we can create new variables, just like Excel. But if we want to see what variables we already have, we can go to our variable view. And then we can take a look at our variable names. Often it's a good idea as a general convention to have nice short variable names so that when you're entering them into syntax or utilizing them as you're doing your analyses, that they're easy to reference and know what they are. And then what you can do is have a label, you can widen this a little bit, to describe more particularly what each of these things mean. So what we're going to take a look at is our gender and race and ethnicity values, and we are also going to take a look at our treatment scores. So I'm actually not sure, this is sort of just a sample data set that was, used in this course previously. I'm not sure what the treatment was, but that's okay. That doesn't matter for the purpose of just getting comfortable with SPSS and getting comfortable with the data. I'm sure that we'll find out more as the course goes on if we continue to use this data set. So one of the first things to note on here is that each of these variables has values. So you can see that if we click on the tab to the side showing the values, that when we look at these, the number 1 is for female and number 2 is for male. And if we want to know what we have in terms of race and ethnicity, you can see this with the 3 dots right next to it. That's so you can edit it. We can see that 1, African American, Asian, Hispanic, Native American, and white are the 5 different race ethnicity categories that we have. If you're not going to make any edits and you just want to look and see what's there, often it's a good idea to hit cancel just to make sure you don't accidentally make any changes. And then we have age. Let's see, how did we divide up age in this data? We have some people under 30, some 31 to 45, some 45 to 60, and 61 and older. So now we know some of what the data is in here. We can note that each one of these is a nominal variable. We talked about that, I believe, in the first day of class. These are categories that can't be ordered in any way. But for purposes of doing some comparative analyses, it's good to know that we also have some scale variables. So we have these treatment scores for pre-treatment, mid-treatment, and post-treatment. So we're going to take a look at those as well today. There are also some variables in here that don't have labels. So we don't know what the different values that are for religion. And that is indicated in the that document that Callie had previously, an exercise in order to make those labels. But since I don't have the source information, we don't want to end up mislabeling people and getting that mixed up. So we'll just stick with the ones that are already labeled for now. So the first thing that we want to do, so we know that we have males and females in our data. We know that we have 5 different race ethnicity categories, and we have 4 different age categories. So if we want to see how many people in our data set fall into these different categories, what we can do is some frequency tables. So we're going to go to the Analyze tab. I'm going to make this a little bit bigger. Hopefully you can see. The Analyze tab. We're going to go down to Descriptive Statistics and over to Frequencies. So I just want to see a couple of these basic demographic characteristics and what we have in our data. So I'm going to put gender, race and ethnicity, and age into the variables that I would like to see frequency tables for. And we check and make sure that the display frequency tables is checked there. We're going to hit OK. Now we'll see here this creates an output log document that's going to be really important. This is where all of the things that you request SPSS to do show up. It's really helpful to be able to see here when you're looking back at what you did in order to create these things. You can see that you did a function to look at frequencies. And we're going to just scroll down. So the first thing that it provides us is just an overall accounting of how many observations, or in this case, they are individuals, were utilized to create these frequency tables. So we have 57 people that we have data for, and no missing data. So we know the gender, race, and ethnicity, and age of all 57 of these people. So let's see our gender breakdown. So we have 26, first it'll give us the frequency, 26 females and 31 males. And so that adds up to 45.6% female and 54.4% male. By race and ethnicity, oops, I'm going to scroll down, we'll see we've got relatively few people in the African American, Asian, Hispanic, and Native American groups. African Americans definitely more at 20%, but pretty few in the other groups, only 5 to 7 people. Though I will say that Native American usually is a much smaller proportion of most populations, so we have a pretty good representation of Native Americans in this data. And white makes up almost half of our sample participants at 45.6%. And for age, we can see that 20% are, almost 20% are under 30. The plurality, the highest proportion, are in the 31 to 45 age range at 45.6%. 22% are 46 to 60, and we have 7 participants, only about 12% that are 61 or older. So this is always a good idea whenever you have new data, find out who's in it and what do we know about them. We don't know a whole lot right now, but we do at least have some of this demographic data. So one thing that we have that's perhaps more substantive to know is we have their pre and post test for our treatment. So what we're going to want to do is to look at that descriptively, we're going to want to create a histogram. So we're going to go to Graphs and to Chart Builder, on there, and then we're going to want to create a histogram. So we'll go down into this Gallery tab here and click on Histogram, and then we see the most basic histogram here, and we're going to drag it into this gallery area. Now, what we want on our x-axis is the pre-test treatment score or pre-treatment score, and so we're going to drag that over to the x-axis. Now, one warning is that it does give a little bit of a preview here of approximately what your histogram might look like, but that is only a preview, so we don't want to start analyzing or drawing any conclusions about our treatment pre-score before we go ahead and create this chart. So the statistic that we're using is histogram, which the default is to do a count, and we could also do a percent. They will look largely similar. There might be other cases where you want to change that, but we're just going to leave that how it is for now. And we're going to hit OK. SPSS is going to take a second and think about it. It's going to produce a histogram for us with the frequency. So we can see these are pretty relatively normally distributed around, it's very nice that it gives us here the mean of 33 and a standard deviation of 12. We can see the pre-scores are tending towards the middle, some people below, some people above. And then assuming that they received the same test at the post time, let's see how those scores changed over time. So we're going to go do the same thing. We'll go to Graphs, Chart Builder. Now, one thing that's nice is that it remembers what you did the last time, so you only have to change the things that you want to. So we can drag our treatment score pretest out of the x-axis and drag our treatment score post-test in. And we will hit OK. Now we see that we made quite a difference. with her treatment. The post-test is 59. The mean score is 59.47. And we see that actually it looks a bit more of a skewed distribution. We do still have a few people that scored relatively low, but we have a lot more people that are falling into this higher 80 to 90% range. The standard deviation as a result, though, is also much larger. So whereas in the pre-test, we had a standard deviation of 12, we saw that people were pretty more tightly clustered around a mean of 33. With the jump in the mean up to 59, we see that the standard deviation is now 22. So this data is a bit more widespread out. So one of the questions that would lead me to ask is whether there are some individuals in the program that benefited more than others. Is there anything systematic about the people who moved from a mean score of 30 that was pretty tightly distributed at the beginning, the people who moved up to this 60 to 90% range, and the people who ended up staying down closer towards the bottom? We know that we have males and females, so maybe we want to compare post-tests by gender. So what we can do is go to graphs, again, chart builder, and we're going to keep what we're measuring as a treatment post score, treatment score post, and we're going to go to this groups / point ID tab here, and we're going to add a columns panel variable because we want two sets of columns. We want one for the males and one for the females. And we're going to drag our variable gender over here as our panel variable. And that will provide us with the distribution of females and the distribution of males. And we're going to hit OK and see what that looks like. Okay, so in terms of frequency, we do have a real big spike. Quite a few of our men are falling right at that 60% mark, but in both cases, we have, you know, this high scoring spike of 4 people at like the 90 or high 80s mark. So these distributions look relatively similar to me. But what is missing from this histogram is that it's not giving us our nice breakdown of what the means are. So maybe we want to see if the means for these two groups are different. We can't necessarily tell that much by looking at the shape when they're kind of similar and we have a small sample size, as we do. So we're going to go to our Analyze tab, and we're going to compare means and select means. So our question is, does post-test vary by gender? So our dependent variable is the one that we're interested in. That's our x-axis, our treatment score post. So we're going to move that up to the dependent list. And then our independent variable is going to be gender. And we're going to hit OK and see whether that makes a difference. So for females, their post-test mean was 59.04, and for males, it was 59.84. So that is only a 0.8 of a point difference. So that's, to me, that doesn't seem like much of a difference. So it looks like males and females are performing pretty similarly. Now, as a flash forward of what we'll be covering on Tuesday, depending on your sample size, whether this difference is meaningful or is statistically significant, whether we can say that represents an actual difference in scores between, or whether we can be confident that the difference in scores is meaningful across gender, will depend very much on our sample size, and we can do a statistical test to see whether that's different. But we can also just use our brains and see that less than a point difference is probably not something that we should be too concerned about. And that's good news. That means that most likely our treatment did not systematically differ in terms of how well it worked for women versus how well it worked for men who participated in our program. Now, if we want to look at another variable and see whether there were differences, because as you'll recall, we were concerned about the much higher standard deviation and whether this program is working similarly for all groups. And another thing that we might want to check is whether it's working different or similarly for people of color. Now, what we can recall from our frequency table that we did in the beginning is that we have some pretty small groups here. Almost half of our relatively small sample of 57 people is white people. So if we want to do a comparison, it might not make sense to compare each one of these groups separately, because that's putting a lot of stock in each of these, only 7 Asian, Hispanic, or 5 Native Americans to be representative of their racial group. And it makes it a lot more likely that those would be just according to chance, that the people received either high or low scores or whatever they were. So we can gain a little bit more confidence by creating some bigger groups. So what because of white privilege, I'm going to check and see if there's a difference between the experience of white people in the program in terms of their post-test scores and people of color. So what we need in order to do that is to create a dummy variable. And so how we create a dummy variable is we go to the Transform tab, Compute Variable. Oh wait, we need another step first. I'm going to cancel that. First, we're going to go back to our data, and we need to check and see what the values are that we want to use to create our new variable. So we go to our variable view, looking at the tab down on the bottom, and we click on the little edit box right here next to under values for the ethnicity category. And we see that our data is coded, the ethnicity variable is coded such that the values of 1 through 4 are all different people of color, and 5 is white. So we're going to make a note of that. We know that when we recode our variable, we're going to want everyone who has a value of 1, 2, 3, or 4 to be coded as a person of color, and everybody who has a value of 5 to be coded as a white person. I'm going to hit cancel. So now we know what we want to do. So we're going to go to Transform, Compute Variable. So we're going to create a target variable called POC for people of color. And POC is going to equal 1 if, and so we're not going to include all cases. Not everybody is a person of color. So we're just going to assign the people of color as a 1 if their ethnicity category. I'm going to add that here. If F is less than or equal to, so we can either type that or we can utilize this button here, is less than or equal to 4. So that will include people with a 4, 3, 2, or 1, which were all of our non-white categories. We're going to continue, and we're going to hit OK. Now this will give us a nice output here showing that if ethnicity is less than or equal to 4, people of color equals 1. Okay, now we need to change that variable for the white people. So we're going to compute variable. We're going to keep this target variable of people of color. We're going to change it to 0 because they're not people of color. If, and instead of the people less than or equal to 4, we're going to just include the people whose ethnicity is equal to 5. We'll hit continue. We'll hit OK. We do want to change this existing variable. It's not going to change our values that we already set as 1. It's just going to add the values that we're changing to 0. So we have that there. Now very important step is to check our work and make sure that we did this transformation properly. We don't want to be drawing the wrong conclusions. So we're going to go to the Analyze tab, to Descriptive Statistics, and we're going to do a crosstab. A crosstab is essentially comparing two different variables. So for our rows, we want to look at race and ethnicity. And for our columns, we're going to look at our new variable, POC. We're going to hit OK. So now we can check our work here and see that all the people with a race and ethnicity of African American, Asian, Hispanic, and Native American all have a POC value of 1 because they are people of color. And we have all the people who were white have a POC value of 0. So we made our variable right. So the next thing that we want to do is go back and create another histogram comparing people of color and white people. So we're going to go back to our chart builder. Unfortunately, it saved our information from when we were looking at post scores compared by gender. So we're just going to scoot gender out of there, scroll down, and move people of color over as our panel variable. See, again, you can see here we only have 2 categories. So it thinks that we might have more categories. So this preview function is not really helpful. So we're going to hit OK and see that it did work properly. We do have different functions, or I mean just the 2 comparisons. So 0 is for the white people because they're not people of color. And we can see that their distribution does look a little skewed upward towards, I mean, we do have 4 people that each got 40s and 60s. But we have, a lot of people that received scores over 80s. Whereas for the people of color, we just have 2 spikes of 4 people, and they are both at the 40 and 60 mark. It looks like a few more did receive higher scores than received lower scores. But, just eyeballing it, it looks like maybe the white people have a little bit higher post scores. But so we can look at that and do our compare means. Let's find out. We'll go to Analyze, Compare Means. And we're going to continue to look at treatment score post. But instead of looking by gender, we're going to use our new POC variable and hit OK. Now we see that the people of color had a mean post-test score of 55.65, and the white people had a mean post-test score of 64. So whereas we only had about a 1-point difference between males and females when we looked at differences in post-test results, this is actually almost a 10-point difference in post-test results. So we might have reason to be quite concerned that our intervention is working more effectively for white people than for people of color who participate in it. But now, again, it might just be, according to chance, that these differences are here. We only have, not a ton of people in each of these categories. So what we're going to learn next week in class is how to tell whether these differences are statistically significant. One additional, well, we'll stop our SPSS lesson there, except for we need to know what to do with this stuff. So if you are preparing your SPSS output and you've created all the right graphs and tables that you want, and you want to be able to put these things into Word, one thing that you can do is go ahead and export your output as a Word document. So, and there's a couple choices here. There's all and all visible. So if you, for example, made several mistakes and had things that you did not want to be shown, you can utilize these little plus and minus functions here to show your graph or hide it. So each request that you made of SPSS creates a new log with a plus or minus here. So you can just go through and select the things that you know you want to keep. Oftentimes, when you make a graph, you do end up having to go back and edit it and change your labels and make sure that things are really clear in SPSS so that you don't have to end up trying to edit these things once you're writing up your memo and your problem set in Word. So you might have mistakes that you don't want exported, and if you've been working for a while, those can start to add up. So you can either do all visible if it's everything that you wanted, or you can just do, you can do all, everything that you ran, or you can just do all visible, the ones that you, selected out as wanting to keep. And you'll want to change your document name. I called mine Lab3 in order to save it. And so let me back up a second. In order to save these things, I went ahead and created the default puts you into your own student account. So mine is mjarpy for my CNET ID. I went into documents and I created a folder for all of my 485 stuff. And so I'm calling this Lab3. I had saved it previously, so I'm going to go ahead and replace it. And I'm going to hit OK. So it's going to export my output to make sure that that does not get lost. The other thing you can do is you can just save your output directly in SPSS. And then that way, when you open it back up, you can, if you go through the remote desktop again and you open it in SPSS, then you can go through and edit your graphs like I had just shown. You can double click on them, change your labels, different things like that. And again, I titled this lab, and this file is called an SPV file. And I'm also going to replace that. So I can close my output. And then I also want to go ahead, because I created a new variable and I want to make sure to save that, I can go ahead and save my data set right in my same folder, save, want to replace it, so that we have that. And then closing this will exit SPSS. So you just always want to make sure before you hit that X box on this main window that either has your data view or variable view, that you have saved everything that you need. And we're not gonna, I already saved the output viewer, so that'll replace that again. And then it's probably a good idea to go ahead and email yourself any of your documents, email them to your group, things like that, just to make sure that you have them all saved. So that is our lab session for today. I hope that was helpful for you. Feel free to email me any questions, and yeah, I'll see you next time.